Welcome to the hydraulic excavator setup and use guidance video. In this video, we will cover the basics of machine application as it relates to the setup and use of the hydraulic excavator in the mining application. Although not all-inclusive, it does cover a great deal of options and basics to safe efficient production while getting all of the expected outputs of the machine. Excavators should work on a bench as level as possible. Use a dozer to prepare benches prior to operation. Expected outcomes include but are not limited to less strain on the machine, increased stability, reduction to damage potential, and an increase the component life of the undercarriage components, swing system, mechanical and hydraulic components. Optimal excavator maneuverability. Improved working time as prep work has been completed. This will maximize excavator productivity. In this topic we will discuss the advantages of the truck located on the bench below, rather than the less productive option of same level loading. The first point to make is that bench height plays a substantial role in the success of the productive aspect. The bench height will equal the distance of the excavator stick, which should in turn be the same height as the dovetail of the haul truck. More on bench height pros and cons will be discussed later. Advantages to this position include: the operator has a top view of the excavator attachment and truck body. Selective digging. Faster excavator cycle time. Fast truck exchange time in maneuverable areas. Narrow swing angle. Allows different position for the truck, 90 degrees, 45 degrees, drive-by. Best practices include: the bench height must be adapted to machine size. Bench must be prepared and leveled. Dozer support is essential for bench preparation, floor cleaning, and bench maintenance. The bench must be strong enough to provide stability for the machine plus bucket payload mass and extra force generated during digging process. Angle of repose of material and fragmentation is critical for machine productivity. As mentioned, the bench height is very important. If the bench is too low, poor fill factor of the bucket due to inadequate material available in the digging envelope. Longer hoist time for the excavator to reach the truck body, resulting in longer cycle time. More excavator repositioning. Risk of bucket and track contact due to potential undercutting to reach full bucket fill. If a truck that has lost view, it can come into contact with the excavator. Toggle linkage will be vulnerable to ground contact during the curl of the bucket. If the bench is too high, the excavator may not be able to reach the floor. This may create a sloped floor which is difficult to maintain. Difficulty to reach and fully load the truck. Increased exposure of the truck tires and body to material. Increased stress on the equipment. Pass width is determined by the position of the outer right-hand tooth which forms the next bench. The standoff range on the left side of the machine ensures machine stability. Machines should be able to properly distribute the load in the truck tray. Remember, minimum safety clearance of 1.5 meters at the front of the track. This will help reduce potentially making contact with the track with the bucket tooth. Digging width should not be larger than 2 undercarriage widths without positioning the truck inward, reducing the swing distance. In this example, the systematic setup allows for uniformity and the ability to process the bench so the next work area can be drilled and blasted. Machine digging guidance. Ideally, tracks are parallel to the length of the bench with sprockets at the rear. If bench stability is critical, tracks should be oriented 45 degrees, but this will generate more excavator repositioning. Dozers can help maintain the bench angle of repose and clean the floor between passes without disturbing operation. Pass width should be in the range of 1 to 2 undercarriage widths. At the end of the bench, the backhoe operator should change track position, remove this final block of material, and then begin a new cut. Once the end of the bench is reached, we recommend the excavator tram back to the front to start a new cut. However, many mine sites have adopted the pattern as identified in the diagram. Impact on travel ratio is an extra 2% to 3% depending on the width of the cut. However, overall machine productivity is improved due to a more efficient loading cycle. This process will ensure constant productivity and a systematic approach to area removal, allowing for timed progression of work area turnover for drill patterns. The bucket loading sequence. To optimize cycle time and bucket fill factor, it is important to adhere to the loading sequence. The operator must not close the bucket too quickly, otherwise the bucket will not be filled correctly. Also, the distance from the edge reduces the risk for trackpad collision. 1. Place the bucket in the correct position. Bucket teeth must be parallel to the ground for optimal penetration. 2. To penetrate the bench, start closing stick angle and slightly raise the boom to ensure a good bucket fill. Do not close the bucket yet. 3. Once the stick angle is closed, about 90 degrees, close the bucket to finish filling the bucket to keep the material inside. 4. Raise and swing the attachment for placing the material on the truck. As indicated in the example picture, the loading of the bucket should occur within the green zone. If digging within the red areas, there runs a risk of damaging the side frames and rollers. Truck spotting positions. Over the side loading, perpendicular to the bench. Swing angle, 90 degrees. Tires are less exposed to debris, if the material is potentially detrimental to tire life. Safe for trucks. Easy maneuvering. Loading through the tail. It is not recommended if trucks are undersized. Through tail loading allows for fewer tires that will be exposed to running over material. Less backing movements of the truck and material placement is more easily controlled. Reduced material lifting effort. The boom of the backhoe does not have to be hoisted over the truck sideboard. An increased ability to read of the truck payload indicator. The drive-by and modified drive-by can be utilized when the backhoe is set up on a long straight run and the bench has good stability. Truck tires and sidewalls are also more exposed to potential damage, depending on the type of rock loaded, so this technique is not recommended in hard rock material. A narrow target for dumping can impact the cycle time. The trucks can be spotted directly on the backhoe side, no need for reversing the haul trucks except the minimal amount in the modified version, which still allows for minimum truck exchange time. Double benching, also known as split benching or double flitching, should only be used if best practices are applied. Advantages. Higher bench heights allow for a more effective drill and blasting program. Same loading point for a longer period of time in operation. Less excavator traveling. Easier for planning. High production if best practices are applied. Less dozer support is required. Best practices. Material should be very loose and well fragmented. Keep a safe distance from the high wall. Leave a trench along the dig face to catch raveling material that may damage the machine. While digging the upper bench, the cab must be on the opposite side of the high wall. If those points are not respected, then this operating method can be unsafe and seriously damage the equipment. 1/3 of the bench below the excavator and 2/3 above the ground level of the excavator. If the first bench is too low, then collisions can happen. 1. Excavating the higher portion first, advancing the face. Boom down pressure should not exceed predefined parameters. This means the material must be well fragmented and collapse under the free weight of attachment. 2. Digging of the lower portion on the way back using standard backhoe configuration. Retreating. In loose and well fragmented material, the following method is recommended. Excavating the higher portion first. Start digging a trough into the bench in front of the machine down to reduced level, RL. Because the material is running freely, the flow of material will continuously feed the trough. Lower bench height must be controlled carefully as the excavator is moving forward. Loading out bench, retreat bench. When the end of the cut is reached, the operator can load out the bench that the excavator is positioned on using conventional digging and loading methods. Once the lower bench is loaded backward, repeat this procedure for the next pass.